Okay. Okay. Can you hear me?
Yes, Doctor.
Can I? Okay. Okay. So today we're discussing last semester questions. 2021 semester 1. This semester now is semester 2, 2021. So this is the last semester. Is online exams. Okay, 4 questions. Okay. So for your informations, for this time around, we have 4 questions. The format is 4 questions. We have 4 question formatting. Okay. And then you have to answer all questions. Okay. You have to answer all questions. Question 1, 2, 3, and 4. Last semester, they give you the whole exam question set. Q1, Q2, Q3, Q4. Okay, start from 9 p.m. until 11:30. But this semester, they changed the formatting. So they will ask you to answer question 1 first, half an hour. After finish half an hour, you have to stop writing and then scan PDF, upload your answer in e-learning. After that, you answer question 2. They will release question 2. You answer half an hour, then after that, you scan PDF, you upload, then they will release question 3. Half an hour, then after finish question 3, you scan PDF, you upload, and finally, they will give you question 4. Okay, half an hour, and then finish, scan PDF, and submit. So there are 4 questions separately. You have to download 4 questions separately with 4 different passwords. Do you understand what I say?
Yes, Doctor. Understand.
Understand? More,
Yes.
more, Vijun, do you understand?
Yes, Doctor.
Okay. So the question will be with watermark, UTM watermark behind the questions. Okay, so you can see the image of UTM. So you must be prepared. Okay, there is no options. You have to answer question 1 first, question 2, question 3, and question 4. Okay. So now this is the format, the sample. Okay. Last semester. So I invite our brother to read for me. Yosef, are you there? Yosef.
Yes, Doctor.
Read the question. Question 1.
I will open the file.
There, in the screen. Oh, sorry. I share the screen. Can you see?
A unit feedback system is shown in figure Q1A. Based on the root locus for the system in figure Q1B. What are the values of the open loop poles? Derive the characteristic equation for the system. Determine the angle of the symptom and the intersection of the symptom with the real axis. Find the breakaway point via the root locus plot and validate your answer via calculation. Determine the intersection of the root locus with the imaginary axis and the corresponding gain.
Thank you.
Okay.
One more, B. B.
B. Sorry.
Continue, B.
B. The system is required to operate at damping ratio of 0.5. Find the following: the gain of the closed loop poles, the range of gain K for underdamped region response.
Okay, thank you. So have you
Can
tried? Have you tried the questions yourself? Have you tried the questions?
Yes, doctor.
Have you tried the questions?
No, unfortunately not, doctor.
It's okay. Okay, let's go. Q1A. So what is the open loop value poles? So from the given GS, you can see that the open loop poles will be 0, -1, and -2. Okay. Second part, derive the characteristic equations of the systems. So first you have to find the closed loop transfer functions, which is GS, 1 plus GS is the unity feedback, okay? K, S plus 1 plus K, okay? So this one will be the characteristic equations. Right? Characteristic equations. Can you simplify it? It will be S cubic equal to 0. Okay. So part number 3. Determine the angle of asymptotes and intersections asymptote. Angle of asymptote. Azira, what is the formula for the angle of asymptotes?
Summation pole minus summation zeros over number of pole minus number of zeros.
Itu intersection.
Oops.
Dia ada dua situ, Satu is angle, satu intersection. So angle is n pi divided by 3. Okay.
Okay.
Where n is 1, 3, and so on. So by using the formula, so you will get 60 degrees, 180 degrees, and 300 degrees. Okay. So dia macam ni lah. Macam tu. Okay. Is the angle of asymptote, which is over here, 60, 180, and 300. Okay. Then the formula you said just now, intersections of asymptotes with real axis. Apa dia tadi yang cakap?
Summation of pole minus summation of zeros over number of pole minus number of zeros.
This one,
Yes.
So it will be, there is no zeros, okay? So the poles available is 0 plus minus 1. plus minus 2. And then the poles is 3, the zeros is 0, so it will be minus 1. Okay. Got it? Got it, eh? Inshallah. 4. Find the breakaway point and validate your answer via calculations. Breakaway point, eh? One is from the true locus plot. One is by calculation. Okay, so look at the true locus plot given. This one. Okay, can you see? So tell me, low Jotian, what is the breakaway point approximately from your observations?
Oh, not sure.
Sorry? From the given plot. You have
I'm
to
not sure, sir.
You are not sure? Breakaway point is here. Sini.
0.4.
This one.
Oh, negative 0.4.
0.4. Okay, thank you. Observation. Breakaway is minus 0.4. Okay. Calculations for validation. So how are we going to find the breakaway from the calculation method? More way, Jun?
Differentiate equation.
So you create VS. Okay. So VS is S cubic plus 2S. Then dVS over ds. Okay. Fine, equal to 0. Okay. So can you find the roots for this? What is the roots?
Negative 0.4
And minus.
minus 1.57.
Okay, so we choose this one. Okay, chosen. Pilih. Okay, which is equal to the from the plotting. Okay, so the plotting is the breakaway lies between 0 and okay. Okay, what is the gain? Find the breakaway power. The gain at the breakaway point will be minus 0.4. So the gain will be 0.3. Okay. Okay. Number 5. Intersections of two locus. with the imaginary axis. Sardinan Sakib? Sardinan Sakib?
Yes, Dr.
From the given graph, what is the value of the point to locus intersection with the imaginary axis?
It's 1.4.
1.4.
4.
1.4. Okay.
Yes.
But,
J 1.4.
yeah, G 1.4. Right. From the given locus plot, the intersections is minus J 1.4. Sardinan?
It's plus minus J 1.
Yeah, plus minus J. Plus J 1.4. And what is the corresponding gain? K critical. Sardinan?
Yes, Dr. I'm calculating.
What is the value of gain at K critical?
Yes, Dr. Okay. Is it 5.88?
5.88.
88.
5.88. How you calculate that?
With the help of the equation of S into S plus 1 into S plus 2. And then I put down S equals to J 1.4. And then I have taken the magnitude and the mode.
Okay, and the magnitude. So you will get 0.
5.8.
So 5. Correct. Correct. Huh? So if the plot is not given, okay, if the plot is not given, how are we going to calculate? Oh. Abdul Ghani.
Yes, Doctor.
If the plot of the root locus is not given,
Okay.
how you find the intersections to locus with the imaginary axis?
We have an equation, which is the sum of
Characteristic.
both, yeah, minus the sum of zeros over the asymptotes, number of asymptotes.
I'm afraid your answer is wrong. Root Lewis table and find the range of stability. Okay, so the range of stability is by root Lewis is 0 to K 0 to 6. Okay, so that's why K critical is equal to 6.
So the question is asked for intersection point.
Yeah,
right?
intersection point, yeah, and the critical gain. So the intersections will be from Bruce Lewis table. Okay. So 3s squared plus k equal to 0. 3s squared plus 6 equal to 0. So s is equal to plus minus g 1.41. It's about the same by observations and by calculations. Okay. So if you see this one is what Sardinan Sakib calculate. Okay, it's true, it's correct. He got 5.8, he got 1.4. Then we validate with the calculations. Okay, we got 6. Sardinal circuit 5.8 is okay. It's true, accepted. And the intersection point at Rugani is J1.414.
So it should be 2.
Yeah.
It should be 2, not 1.4.
Yeah, we have 2 ways. One is by observations and one is by calculations.
If you see the equation 3 squared plus 6.
Yeah. So this one is K critical. This one is from root twist. You have to construct the root twist table. Okay.
I mean the value of S.
You know how to
calculate
calculate?
Yeah. But if you calculate the value of S, you will find it plus minus J2.
Yeah. So the root twist table, S cubic, S square, 1, 2, 3 K, 6 minus K over 3, 0, K 0. So the 3S square plus K is come from here. Okay. So you find this K first, which is the K critical. Then you insert inside the question here. Then you get the value of.
So I think you did not understand my question. My question is about the equation, the last equation. It's correct, but the
which equation?
Last one.
Last one.
S equal to 1.14. Can you go back?
This one.
It should be equal to 2. If you say 3 squared plus 6, you take the 6 to the other side, divide by 3, you get minus 2.
3S square minus 6, S square minus 3. Okay.
2.
Sorry, minus 2. Okay.
Yes.
So S.
Okay, you take the square of 2.
Minus square root minus 2. Imaginary lah.
Okay.
Imaginary. This is basic, Brother Abdul. Okay. Are you clear? Are you clear? Okay. Fi mushkilah. Bismillah. Part B. Part B, still the same questions. Part B. So it's given damping ratio 60 degrees. Given. Allah Fahad, what is theta? Allah Fahad.
Cosine inverse 60. Cosine inverse 60.
The damping ratio is given 0.5.
Sorry. 0.5. So this one will be 0.5. Okay.
Or 60.
60 degrees. So you are given what do you call that? Okay. How are you going to draw 60 degree from here?
By taking any value for the y-axis and finding out the x for them. Like 1060 equals to 2 over x. So x will become.
So one way is you print out this. And you print out this, then you draw the 60 degree line. Okay. This is method number 1. Okay, so you get this point, right? Second method.
To take an axis, like if we consider y equals to 2, then we will find out the value of x, like 1060.
Also can. Okay, so there are many ways to do that. Okay, thank you very much. So we choose the first method. Okay. Okay. So this is considered as the dominant poles. Okay. And what is the gain for the dominant poles? $11. Okay. Got it? You got it? The gain K and all the closed loop poles. What is the all closed loop poles? All closed loop poles. So we have the dominant poles just now, which is minus plus J 0.579. First one, second one, and the third one is the third pole. So how are we going to calculate the third pole? Nur Aina Shafika. Aina Shafika, how are we going to calculate the pole?
By using
Kan?
RH table.
Oh ni, mana ni cerita apa? Third pole.
Not sure lah Dr. Datang.
Okay, not sure. Lo Jotian. Lo Jotian.
Yes, sir.
Calculate the third pole. We already know first closed loop pole, second closed loop pole, and what third pole.
S equal to negative 2.32.
How you get that?
Calculator.
In the calculator, manually.
Manually,
Manually.
division.
Division. Division of what?
By using the negative 3.33 divide the characteristic equation.
Negative. Oh, this
By using the first two loopholes.
the first. Which one? This one. Sorry again. I can't.
I think I will like multiply first the first two loophole, then divide with the characteristic equation.
Okay. So by calculator, using calculator, how you use calculator?
You can put down the value of k as 1.04.
Okay.
And then we can find out all the 3 poles.
Okay. So k is 1.04 here. Am I right?
Yes.
1.04. So in here is cubic. Okay. But you know the first one and the second one, right? Okay. So in fact, this one you can. What do you mean that? You can factorize. Am I right? S square plus 3s plus 2, right? Plus k, 1.04, correct? Hello, guys.
Yes.
Okay. So this one will be s plus 0.333 plus j 0.579. Right. This one is s plus 0.333 minus j 0.579 plus 1.04 equal to 0. Okay, if you factorize, but this value, okay, and then you find the s. So s will be minus 2.34. Next question is the range for the gain k for underdamped region response. Range of k underdamped region. So we know that Kc is 6.0. K breakaway is 0.388. Okay. So the k under dam will be here. Between the critical and the undammed. Okay. So it will be so the underdamped region will be here. Okay. Underdamped region. Finish question number 1. Question number 2. Ali Imran. Ali Imran. Ali Imran, are you there? Tak datang. Tak datang, eh? Abdul Rahman Syarudin.
Yes, doctor.
Question number 2, please.
You want me to read it?
Yes, please.
Alright. Figure Q.2a illustrates a unity feedback system with a forward transfer function of a plan for a stack input. where GCS is the controller of the system. The open loop transfer function GS is given as shown in the figure. For the uncomposited closed loop system, when the system is operated at 18% overshoot, the damping ratio at this instant is 0.48, whereby the natural frequency is 2.75 radian per second. Identify the dominant poles, settling time TS, and the peak time TP for the uncompensated system.
Continue.
Overshoot to A2, the system is required to maintain the operation at 18% overshoot, while the settling time is reduced threefold from that of the uncompensated system. Design a controller to achieve this specification.
Continue.
Okay, a vehicle suspension system is represented by a block diagram shown in figure Q.2b1, where K is the gain controller of the system. The system has a root locus shown in figure Q.2b2. At a particular value of gain K, the system response of the system is shown in figure Q.2b3. Design a PID controller GCS by using Ziegler-Nichols tuning method to replace the gain controller K. Use the Ziegler-Nichols PID tuning parameters as available in the appendix A.
Okay. So no plot is given. Raman? Abdul Rahman,
Yes,
no plot is given.
the plot is given.
Ada plot tak given? Any graph given?
No. Ada.
Oh, B ada. Kan? B ada. So A tak ada.
A don't have.
There is no plot for A. No plot given. So we just been given open loop transfer functions. Okay, unity feedback. Then closed loop transfer functions will be okay. For the uncompensated closed loop system, when the system is operated overshoot given 18%. Okay. The damping ratio at this instance is 0.48. So the natural frequency omega n 2.75. Okay. Identify the dominant poles, settling time, and peak time of the uncomposited system. So how are you going to do it?
First, find the settling time, the damping ratio, and natural frequency.
So maknanya you have to dominant poles ni, dia punya formula dia adalah minus zeta omega n, kan, plus minus j omega d, correct? So this is the real part. And this
Betul
one,
tak nampak
oh
screen.
sorry Allah. Let me see PKP ni memang kepala pening sikit. Nampak? Okay.
Okay, nampak tak?
Real part minus zeta omega n plus minus imaginary part. Imaginary part is j omega d. Omega d is omega n 1 minus zeta square. Okay. So insert the value of zeta n omega n. yield. Apa? Zeta omega n 0.48 minus multiply 2.75. Correct. Omega D, omega n value, zeta masukkan, so you will get 2.48. Okay. So this one is the real. And this one is the TS sama dengan 4 bagi real. Okay. Tiga point. EP. Pi bagi imaginary. So pi bagi okay. So that is part 1. Part 2. System is required to maintain 80% overshoot while the settling time is reduced threefold from the uncomposited system. Design a controller to achieve this specification. So what controller are we going to use? Is it P controller, PI controller, PD controller, or PID controller? Omar Khalid. Omar Khalid. Omar Khalid. Ala Al-Fahad.
Yes, doctor.
Controller. 2A2. Question 2, part A, part 2. Just mention that design a controller. You didn't specific mention on P, PI, PD, or PID.
Yes, we will we'll take from the settling time, we take the point. We find the real part.
Okay. .03. .01. Correct.
Is this equal to the 4 over? Do you get the frequency?
So is a PD controller, right? PD controller. So PD design will be S new 4 divided by 3.96. Okay, the real part. Okay.
So now we find the imaginary part.
Yeah, imaginary part.
By over.
So how you find the imaginary part?
By over omega n square omega.
Yeah, I know, but find the angle first. All right, you have to find the angle first. So this one is 3.96. And this one is the omega d nu. Okay. So the angle, what is the angle? Angle is, what is the angle? 18%. Theta is 60 degrees, correct? So the theta is 60 degrees. So zeta is how much? Zeta just now? 0.6.
0.48.
0.4. 60 degrees, more or less. Okay, so tangent 60 degrees. Okay. So what is the new dominant pole? Minus 3.96 plus J 7.24. So we have to draw in order to find the new zeros. Okay. So let this angle as theta 3, theta 2. Theta. Yes.
Like
Yes.
zeta omega n should be equals to 3.96, right?
3.96 minus 3.96.
So from there we can find out omega n. Then based on that we can find out omega d, right?
Yeah. Yeah.
So if we follow that process, doctor, then omega t is 9.15 omega d.
Omega d. The new one, 7.24 after 3-4 reductions. The old settling time is 3.03 seconds. The new settling time is 1.01. Who is asking the question?
Sadnan.
Okay, bye. So this one will be L3, L2, L1. Okay. So summations of poles minus summation of zeros, 180 degrees. Theta 1 plus theta 2 plus theta 3 minus theta c, 180 degrees. Okay, so you have to measure theta 1, theta 2, theta 3, and theta c. Sarina Sakib, theta 1, what is the value of theta 1?
It's doctor.
Theta 1.
It's up to 7.10 theta 1 is equal to 7.24.
Theta 2.
Equals to 10 inverse 7.24 over
180 degrees.
So actually I
180
should have
degrees
to
minus
see the diagram.
7.24, 0.96. Theta 3. Theta C. Okay. So you will get 74.26 degrees, 97.55 degrees, plus 112.24 degrees. Okay. So that is theta C. But theta C actually is located here. Okay. X. So this is the dominant pole, SDP. And the angle is 140.05 degrees. So that's why you have to use a tangent. So we will get GPD KS plus vector 2.15. 2.15. PD controller. Question B. Question B is you are given the plot. Okay. And the rule locus is shown in the figure Q2B1. So at a particular value of gain K, the step response of the system is shown in the figure Q2B3. So it's the oscillations. Okay. Q2B3, Q2B1, Q2B2, Q2B3. Okay. So the figure Q2B have three figures. The first, the block diagram is Q2B1. The rule locus is Q2B2. And the oscillations is Q2B3. Okay, so please correct the block diagram. The title of the diagrams. Design a PID controller by using a Ziegler-Nichols tuning method to replace the gain controller K. Use the Ziegler-Nichols PID tuning parameters as available in the Appendix A. So if you look at the Appendix A, okay, so you're given a table A1, the Ziegler-Nichols table. So what information you can get from the open loop, from the plot given? Azira.
The pole,
Open loop poles.
open
Okay.
poles.
What is it?
Jap.
Three.
My 2 minus 2.
So,
Okay. Oh,
minus,
J plus minus J2.
minus 8.
No minus 3.
Minus 8, comma, minus 2 plus minus J.
J
J1.
oh J1. Oh yeah, J1. Okay.
And then what is the intersections
Intersection.
between
Plus
Rotor
minus 6.
and imaginary axis is at
At 6. 6 and minus 6.
J6. At J6.
J6.
Okay.
Yes.
Which is equal to J omega, which is equal to J omega U. Okay. So omega U is equal to 2 pi FU. Okay. And this one is equal to 2 pi divided by TU. Okay. So TU is 2 pi divided by 6. So more or less you get 1.05 seconds or 1 second. Okay. From the graph given in figure Q2B3. Okay. This one, the graph with the oscillations. Okay. What is the period? TU. Period time. Peak to peak. Peak to peak. Alaf Muhammad. Muhammad. Yosef. What is the period from the graph?
Can you show the graph too?
Peak to peak. Peak to peak. 1 second.
Can you show the graph on the?
Oh, graph. Okay. Yeah. Peak to peak is somewhere here.
From
here to here.
Around 1 second.
1 second. 1 second. Agree? Guys, are you agree?
Yes.
Agree,
Which may be more clear on the in the second 9.
Yeah, sure.
From the second 9 and second 8.
Okay, yeah.
It's more clear there.
As long as the value is 1 second, it's okay, right? So we just write the TU, the period of the oscillations, okay? It lies between peak to peak, correct? Peak to peak, 1 second. And then okay. So this is the critical KU, okay. And this is your pulse, okay. -3 or -8? 0?
-3.
-3,
-3. -8. Sorry.
-8,
-8.
-8,
Yes.
3, 4, 5, 6, 7, -8. -8. Okay. So KU, gain it, KU is L1, L2, L3. Okay, so you can name it L1, L2, and L3. KU is equal to 2 squared, 5 squared, 2 square 7. KP KP divided by TI and KD KP TD. Okay, so that is the PID, Ziegler-Nichols sample of questions for PID tuning. We have 10 minutes. Still ready? Still strong? Can we go for the question number 3?
Yes, still strong.
Yes, sir.
Strong, huh? When is the final exam? What day?
10th of July.
I know the specific date.
10 July.
10th of July.
No lah. No, July lah. I just received email. The exams is on the 10th of July. Hello.
Yes.
Control system design Saturday 9 a.m. 10th of July. Please jot down in your diary. 10th of July. Right. Nuraina? Nuraina? Nuraina mana? Sebelah. Ramai kita. Malas ni budak. Zira, bacalah question number 3.
Question 3. A closed loop system for control of a mechatronic system is represented in a block diagram in figure 3.8 with GS equal to 800 over S plus 2, S plus 10, S plus 100. With K equal to 1, board plot of the system are shown in figure 3.2b and 3.3 Q.3c. A. By analyzing board plot, find the gain margin and the phase margin, the position constant Kp to a unit step input. This value can also be calculated using a formula of the steady state error, and discuss the system stability. B. The steady state error of the system is unsatisfactory. Therefore, the position constant Kp must be increased 10 times. Calculate a new value of gain K to achieve this objective. C. Using the given board plot in figure Q3.B and Q3.C, sketch the board plot with the new value of K in B. Design the objective in C. The system is also required to operate with an overshoot of 10%. Design a lag compensator to meet the requirement. And E. Draw a complete block diagram of the closed loop system with the lag controller.
Thank you very much. Question number 3. So board plot is given 3B and 3C. Okay, very nice plotting using Excel. Okay. So K equal to 1. Find the gain margin and the phase margin. Oh. Abdurrahman.
Yes, what's that?
Gain margin and phase margin. Gain margin first.
Imagine we look at the phase diagram,
Hmm.
negative 180, and then
What is the omega GM there?
12
12.
12 radian per second.
12. Astagfirullah. Clock
Okay.
scale tu Rahman. Clock scale tu 10, 20, 30, 40, 10, 20, 30, 40 mah. Astagfirullah.
Sila baca.
Kau pakai spek ke? Kau pakai spek ke?
Pening PKP.
Kan? Kau pakai spek tak?
Tak.
Okay. Okay. What is the omega GM? There. Frequency over here. I think 35 kot. Huh? Sini, 35 kan? 10, 20, 30, 35 Okay?
Okay.
Okay, agree Okay, agree. Then 35 is here. Here. What is the value here? The dB?
4.
5 good. Schema 5. Gain margin 5. 5 decibel. Okay. IE 0 minus 5 dB. Okay. Rahman.
Yes.
Phase margin.
25 radian per second.
Phase margin and gain curve 0 dB. Yeah.
Yes.
What is the frequency over here?
25.
25. Boleh lah man. 25 radian per second. What is the phase margin? Yeah. What is the phase? Roughly minus 170.
70.
Minus 170 minus 180. 10 degrees. Okay.
Doctor, what is usually the range for answer scheme?
Plus minus 1. Plus minus 1 is okay. Okay, look at my answer. Okay, so omega GM 35 radian per second. Gain margin 5 decibels, which is 0 minus 5 dB. Okay. Omega phase margin, as Rahman said, 25 radian per second. And phase margin is minus 170 minus 180, which is 10 degrees. Okay. Part B, number 2, the position constant Kp. Look at the graph. So this system is type 0, type 1, type 2. Yourself. type 1 or type 0, type 1, type 2? Yourself?
Yes, doctor.
By looking at the GS, open loop transfer function, system is type 0. So there is a KP inside. So what is the initial value of the gain curve? What is the initial value?
Someone wrote in the chat type 0.
20, 40, 24, 24, 20,
24 or 30, around 30 or 30 something.
28, 32, 36, 40, meaning that this one is 36.
32.
32, sorry, 32, huh? So 32, meaning that at the initial, the 20 log KP is equal to 32 decibel. Okay. So Yusuf, how to find KP from here?
20 lakhs. Just calculator.
Please. $39.8, huh?
32. Yes, doctor.
Now,
Yes, doctor. Now.
Okay. Sahih.
Sahih.
All right. This is the first method to get KP value from the graph. The second method is by using formula. Okay, so the formula is KP
Type 0. The limit of KGS when S goes 0.
Correct. 80,000. Okay.
20.
Jawapan? Answers?
A 1,000 over
40. 40.
Yes, doctor.
What is 40 in Arab, Yusuf?
Yeah, it's easier to
40.
delete the zeros.
No, in Arab. What is 40 in Arab?
40.
40. 40. Arba.
Or 40.
Is 4. 40, 40.
Yeah, 40 أو 40.
40. Malaysia kata 40.
40.
So, the closed loop stable or not stable, Rahman? Closed loop system is stable. Okay, B. The steady state error of the system is unsatisfactory. Therefore, the precision constant Kp must be increased 10 times. Calculate a new value of gain K to achieve this. Kp new. Currently 40. Increase 10 times. Correct? So now you become 400, correct. Okay, KP new is 400. So by using the formula, 80,000 K multiplied by 2, multiplied by 10, multiplied by 100. So the new KP, K will be 10. Okay. Using the given workload in 3B and 3C, sketch the workload with the new value of K. So you have to sketch. How are you going to do that? First, you calculate first 20 log K, 20 log 10, the new one. So is a 20 decibel, correct? So the magnitude curve of both will be shift up, yeah? Shift up by 20 decibel. Okay, by 20 decibels. So this is Joseph. This one is 30, 32. Am I right? Okay. 32 plus 20 berapa?
52.
52. So 52 kat mana? This is 40, 44, 48, 52 here. Okay. 52. So you just shift here like this. 20. You make sure that the old one and the new one is about 20 decibels. Okay. So shift up. Shift up. Just draw like this. Okay. If you have a printer, you print this one and you sketch like this. I understand. But if you don't have printer, you just sketch lah. Freehand draw. The black one is the old one. The red one is the new one. Can you do that, guys?
Yes, Doctor. Can.
Yes, can.
Can, okay. And then part D. Draw. Sorry. Beside the objective in C, system also required to operate with an overshoot of 10%. Design the lag compensator. Okay. So overshoot 10%, if you use the graph behind, okay, behind the question, the appendix will give you zeta 0.59. And 0.59 will correspond to the phase margin 58 degrees. All this by graph behind the questions. Okay, question exam. So to obtain 58 degrees, to obtain phase margin 58 degrees, okay, so at what frequency? Omega PM. Raman?
Doktor tak nampak.
Oh, tak nampak? Tak nampak. Okay. So I repeat again. To obtain overshoot is 10% is given, kan? So you have to design the lag compensator. So in lag compensator, if overshoot 10% is given, so the zeta is 0.59. How I get that? From the graph given at the back of the questions. Okay. And from that zeta, we will get the phase margin 58 degrees. Okay. So all this by using graph behind the exam questions. So to obtain 58 degrees, okay. So what is the phase, the omega phase margin needed there? Okay. So I show you the standard graph first. Okay. So this is the graph of the phase margin versus damping ratio. This is the overshoot and damping ratio. So 10% here will give you zeta 0.59. Okay. Okay, and zeta 0.59 here, 0.59 here, roughly about here, will give you the phase margin 58 degrees. Okay. So you use this. Okay, you use this 58 degrees as our target. Okay, phase margin here. So to obtain the phase margin 58 degrees, so what is the value of the phase? 180 minus 58, how much? 180 minus 58.
122.
122. Okay, so you find 122 here. 122. This is 90. 122. So satu segmen ni berapa man? 10 kan? 45. Maknanya 45 bagi 10, 4.5. Satu segmen ni 4.5. So 58 degrees is somewhere ni kan, ni minus 45. Sorry. Tadi apa tadi man? 180 minus 58.
122.
122. 122. So this is 94. 122. Ni tolak lah. 135, 131. Somewhere here. Okay, somewhere here. 122. Lebih kurang kat sini lah.
6 maybe.
No. The answer is 9.
Oh.
9 radian. Ni man. 1 sini man. Ni 2. 3. 4. 5. 9. Ini 11. Ini 20. 30 man. So 9 So this is minus 122. Okay, so the omega GM is about 9 radian per second to achieve phase margin 58 degrees. Okay. Click on drawings. So 9 radian per second. So the light controller, or I usually call light compositor. Here is 9. 9 kan, 9 radian per second. So 1 decade after, 1 decade before, 0.9 radian per second. And then you extend minus 20 dB line. Then straight, so you will find this one is 0.13. Okay, so 9 radian is here. So in order to design the light compositor, you have to find 1 decade before 9 radian per second, which is 0.9 radian per second. After that, you extend the minus 20 dB line, okay, until you reach 0.13, and then you straight away, okay. So you find that the G lag
How do we get that 0.13?
0.13, roughly, this one is 0.9. So satu decade of 0.9 is about 0.09, 1 decade, okay. So sampai ke situ je you buat straight line. So roughly is 0.13. Okay.
Okay, I see.
If you write 0.1 is okay, 0.11 is okay, 0.12 is okay. No problem. As long as the zeros is bigger than the poles. Okay. So 0.9 plus 1 and as 0.013 plus 1. Simplify. Okay. So now your light compositor completed. Input is R, output is C, G light. Okay. All right. So draw the block diagram. This is the block diagram. We continue tomorrow, 12 p.m. Okay. As Wednesday.
Okay, no.
Okay.
To be continue on Wednesday. What date? 16, eh?
Yes.
2021. For question 4 and final exam semester 2, 19/20. Okay. 12 p.m. 12 until 2 p.m. 2 hours. Okay. Thank you very much for your listening, and I will share the recorded, okay, after this. So questions? Yes, sir. Mic not working, sir. Type 0. How to know the type? Still confused. Astagfirullah. Rahman. Oh, Rahman.
Yes, doktor.
Kita ganti-ganti. Kau tengok question 3 tu. GS dia apa? Question 3. Oh, Rahman.
8,000 over S plus 2, S plus 10, S plus 100.
Okay. So what type is it?
They said that it's type 0.
S plus 2, S plus 10, S plus 100. Ini type 0. Okay. Kalau dia macam ini, 80,000, S plus 2, S plus 10, type apa?
Type 1.
1. Ini kan S power of 1. Ini S power of 0. Kalau dia macam
Oh.
ini, 80K, S kuasa 2, S tambah 2, S tambah 10.
Oh, type 2.
Type 2.
Alright.
Faham lagi. Kalau tak faham lagi, lebih lah. Jadi biasa type 0 correspond pada KP. Type 1, KV. Type 2,
KD.
KD.
Acceleration.
Acceleration, velocity, and position.
Right.
Must adapt ni. Kalau tak, outcomes tak sampai. So, any questions? No questions. So, I see you, inshallah, on Wednesday, 12 p.m. Okay, until 2 p.m.
Okay, thank you so much, Doctor.
Thank you. Bye-bye.
Thank you, Doctor.